Hello everybody, this is Akanksha Singh and I'll be taking you through the entire series of maths and science.
Hey friends, today we're going to do separations of insoluble substances from water. Now, this is a topic of subject science under chemistry. Probably in class 6th, we have a chapter called separation of insoluble substances from water. Now, before talking about uh, how do you separate insoluble substances from water, I would like to first discuss a quick recap of what we have studied about matters earlier. Now, how many states of matters exist? The answer is three, right? So there are three states of matter that exist. One is solid, the other one is liquids, the third one is gases. So we have briefly discussed about solid, liquid, and gases. In solid, we had seen that the intermolecular attraction was the highest. I mean, the molecules and the ions were tightly packed in solid. So there was very less molecular space between the molecules in solids. When we headed towards liquid, we saw that the molecular attraction now is a little lesser than what was there in solids. So in liquids, you can say, so in liquids, you can say that the intermolecular attraction is little less. The distance between the molecule is more than the solids. And heading towards gases. Now, in gases, the molecules were far away, right? So intermolecular attraction was least here as compared to solid and liquids. Now, how will you separate a solid substance from water? That is the question. And discussing these questions, we'll be moving towards the subject today, the topic today, which is separating the insoluble substances from the water. Now, what are insoluble substances? Before moving ahead, insoluble substances are those substances which cannot be dissolved, right? So, how do you separate such substances from water? Now, heading towards the first process of separation, that is sedimentation. Now, to separate an insoluble substance from a mixture with water, the simplest technique is sedimentation. Now, in this, insoluble substances settle down slowly and slowly, and water is poured off slowly. Now, this is something like, okay, I think if you have been into kitchen, the rice, when you wash rice, when you pour rice in water, what happens is the rice settles down and the water above uh, clearly separates. Now, what you can do is you can easily pour off the water, right? Similarly, when you take up sand, if you take sand and you put it in water, what will happen? The sand will settle down and you can pour off the water. So here there's one simple flow chart explaining how sedimentation works. Now we have mixed sand and water. Now when you mix sand and water in a beaker, now how does a beaker look like? This is a little messy beaker. Now this is a beaker and it has water content, right? Now in this, when we pour sand into it, right? Now when you pour sand, it settles down. It settles down. Now slowly and gradually it settles down. Now what happens is after some time, you can easily pour off the water from the mixture, right? And that will give you separate sand and water, right? So this is how you can perform sedimentation. Now, sedimentation says that any insoluble substance, when put to water, when put inside water, the insoluble substances will settle down, and you can pour off the other liquid. Okay, so this is sand plus water example that we took in sedimentation. Now, moving ahead to filtration. Now, the insoluble substances can also be separated by filtration. The pore size of filter must be smaller than the insoluble substances to separate out it from water. Now it says that you can filter the things. For probably, I think the best example of filtration is when you make tea. When you separate the uh, tea leaves from the tea, what you do is you use a filter, right? And the size of the pores inside the filter are smaller than the size of the tea particles, right? So therefore you are able to do filtration. Similarly, for any kind of filtration, what you can do is you can take up a filter paper. For example, in chemistry lab, I think you would have regularly seen there's a filter paper for removing sand and all that particles. So you can take up a filter paper, make a cone out of it, and put it above the beaker and pour the sand and the water mixture into it. Slowly and gradually, the sand will separate out and the water will go inside. So that is filtration, right? Moving ahead to separation by alum. Now, alum is something when you mix with water, what happens is all the dirt or all the sand gets sticks to the bottom of the beaker, right? Alum lets the dirt or the sand or any insoluble particle to stick to the bottom of the beaker, and this easily helps us to pour up the water. Like sedimentation, there was a risk of there was something that you have to do carefully, but when you mix alum with water, sedimentation becomes even more faster, right? So this is the third process that you can use for separating insoluble substances. Now, moving ahead to my favorite ritual, which is homework. I am giving you the homework. These are the three questions I would like all of you guys to answer these, fill in the blanks in the comment boxes and let me know the answer of the same. And thank you, class. Thank you for watching my video and cooperating with me. Thank you so much.